Is this, can you see it, please?
Yes.
Okay, awesome. So I'm also going to be trying to make it as quick as I can. So, I'm just going to talk about how we try to use, again, during COVID, try to use a tool called Tinkercad for doing an embedded systems type course and what came out of it and what design students did. So first of all, oops, next. Okay, this is where we are. This is Houston, for those of you who are not orientated, just to give a very brief idea of the United States, and we are right there. Slide. Okay. So just a little bit about, again, our university. So we are also called as the Houston's only Catholic university. We are 147. We are accredited by the SAC. SACSI, it's called, very diverse institution. We are Hispanic serving, Asian serving, minority serving, etc. This is who we are. I just wanted to give a small shout out to who us as an institution. Okay? And just to give a very brief intro to our institution. So we are University of St. Thomas in Houston. Okay, so the motivation for this talk, basically, we all know COVID. COVID meant that we needed to have a lot of changes. That meant, educators needed to come up with online classes, exams, and administrators needed to come up with a lot of money to invest in technological resources, right? And that meant some had money, some didn't have money, some were, even though they had money, it was a little difficult to access it and to sort of deploy certain things. However, we still want to give quality education. We still want to enable our students to do something with their hands, and be able to share the work, to be able to collaborate about this, and also to do all of this if possible with no cost or minimum cost. So it turns out there's this tool which is called Tinkercad. It fits this bill pretty well. And Tinkercad is a free 3D design tool, which is web-based. It can also do electronics and a little bit of coding as well, can be done through that. So it's made by AutoCAD, which does AutoCAD, sorry, Autodisk, which also does AutoCAD and all, but that's the company that makes it. This is the symbol. So it's supposed to be free for everyone. It is easy, and it's safe for kids. So in other words, most of these people that use Tinkercad use at this high school. Like it's not necessarily something that universities might want to use, simply because universities do have access to other tools that are more capable. By the way, just wanted to mention, not sponsored, right? We all have to say this. I only have a free account. I'm just very grateful for Tinkercad because they make this available free. Okay, so the way I organize this course is pretty straightforward. I'm not going to, the real aspect was to introduce Python language, to kind of help them to learn how to code, how to debug, and to introduce the single board computers, such as Arduino and Raspberry Pi, and also some very basic electronic hardware, the bench work. These are all the scope of the course. Breakdown. We had a few assignments, and mostly it's all project based. So project 1, 2, and 3 projects, and a little bit of assignment here and there. That essentially was more of a hands-on type of a course. Unfortunately, COVID came, so we had to do something, and I'm going to skip this. So first thing what we did was, I asked the students to basically, the project I gave them was to work on a toy drone. So they buy a drone, we bought the drone, and to disassemble the drone and to assemble it back and make it operational using Arduino. So essentially, the idea is you should be able to control a drone. It should fly, but then the control should not be from a controller with your hands, but through software that is on an Arduino. So that's the goal. That's the idea. So the task for this class was they had to study about drones, which is what they did. Here's a screenshots of the of the of the presentation that students made. So one student talked about what are the different types of drones, how they work, how to fly them, and somebody else talked about, well, what are single board computers. Another one talked about radio, wireless communications. How does the radio really talk to how does the controller, wireless controller, talk to the actual drone to sort of fly? Okay, so those are some of the very basic things that they have to do with design. And here is an example of Tinkercad. So this is a tutorial on Tinkercad. So this is very simple image, which it has a single battery. And online, what you could do is you could actually kind of model. This is an image of that is present available online. And here is the code for running. So you're emulating. If this code were to be written and put on this Arduino, this is how it will work. So you can actually write code, upload it electronically or virtually onto an Arduino and see it work. So that's what we used for the students to develop their circuits. So here is some a little bit more complex circuit in which it's just instead of there is this black box right here is actually a relay. So the relay is now being controlled by an Arduino. Code on the Arduino will open or close the relay depending on how you program it. So here is another final design. So we have about 12 relays corresponding to 12 switches that control 12 things on the drone. And example code. So we are setting up all the buttons. Okay, the forward button is pin 13, etc., etc., etc. And we are going to essentially make all the pins input or output, and then keep on running the code. More examples down here. So what we do is we call it a scene. In other words, we divide about 30 seconds worth of flight time into scenes of half a second each, and then for that half second, what button should turn on or off, etc., etc., etc. And so we have a long 10, 20 page code, which looks like this. We kind of keep going, and here is an actual one LED being turned on and actually it's functioning, as an example. And so kind of this is the whole setup. This, as you can see, we disassembled the controller, which normally would control the drone, but all the buttons are now controlled by this relay right there, and the relays are controlled by the Arduino, which is programmed from the. That's the idea. And so this is a video. I hope this works. So this is testing of the actual drones controlled by a single frequency. So we change the frequency so that it works single frequency. I hope. Okay, that's me. COVID, so I have a mask on there, and so we trying to test out things. And when I turn on, basically the control, I can turn on the drones to wireless, and by controlling those, which pins turns on. So moving on, this is a close-up, so I'm going to skip that. Here is an actual student who was working on her device. She's controlling all the pins except some of the pins that are connected through the Arduino, and the code is downloaded onto there, and that's going to turn on or off her drone. We tied it so it doesn't fly away. As you can see, there's actually picks up, and it should fly away when the control is given. So this is what this. So the point of this is that we were able to. The students designed all of this using the virtual tool Tinkercad, their circuits and everything. And then we had a 3-day meeting, 2 weeks to kind of be in person. Everybody masked up, and we had to do the bench work to get it to work. And then we only got 2 weeks worth of person time. Shipping was the problem, right? And it was hard for me to give students some feedback. But the issue was we couldn't find an equivalent tool for emulating a Raspberry Pi. We were able to do it with an Arduino, but it was hard. We didn't find one for Raspberry Pi. if there's anything out there, then I would be happy to know. So moving forward, if you were to do this again, we probably think we could use a multi-angle camera type system, make the student work more independently and try to work from a kit. And we need to find the Raspberry Pi emulator, which we can use online. So I'm just kind of speeding over here just in the purpose of time. So, our students did a remarkable job given all the constraints that they had. And it kind of proves in our setting that we can do hybrid classes. And for cost effectiveness, we generally buy these toys, which serious institutions may not even consider doing that. But it's cheap. We can disassemble. We can buy multiple of them, and the students love the idea that they can actually control a drone using software. So it worked out well for us in this instance, and so just wanted to present that. And if there are any questions, I'll be more than happy to entertain or pass it on to the next presenter.